Daniel Borrajo, who leads one of the most famous and active groups of planning in Madrid, but also I think in Spain and maybe in Europe.
No.
So for us it's a big honor to have him with us. So please proceed.
Okay, thank you. Well, unfortunately, they just told me to teach, to give the talk in English, so my slides are in Spanish, so I hope that, well, you get the idea. In any case, just interrupt me whenever you want, and we can just talk instead of just me giving the talk and talking all the time. So what I was asked to talk about is on planning, more specifically on applications that we've done in the past related to tourism. So I'll first explain some basics about planning and make some connections with other tasks. And then I'll go into some applications of that we have done in our group, very briefly. In case you want to know more about any one of those applications, just let me know. And then I'll more specifically talk about the two applications that we've been involved related to tourism, which have been sum up and on road. And then, well, conclusions are just one slide, so it's just very short. So first of all, obviously, this is not, well, my work. It's the work by plenty of people, so I'm just here as the coordinator of the group. We have plenty of relations with other groups, and I'm not going to describe in detail. And well, most of the work that was done in the past with SumUp was done with these two groups, with Politécnica Valencia and Granada, and we've been involved in other national projects. And there were more people involved on that project, and I'll describe them later. So first of all, on planning, well, it might be, so my guess is that your group relates to agents. Planning is something that many people know about, not so much. Not all the people know working in AI know about what planning is. So I'm just going to give a brief introduction. If it's too basic, then just please let me know, and I'll just skip it. If you are interested in more, then I can explain a little bit more. So one of the main differences with respect to what most people in AI is worried about is that most people in AI is worried about the task of making simple decisions. So simple in the sense that it's one-step decisions. It's not that the decision is easy to take or to make or how to make that decision, but that the output of the decision is one-step things. So, well, you can have your guess of all the machine learning tasks, recommendation tasks, so all the tasks that have to do with I get an input and I generate an output that is composed only of one decision. So I should give the mortgage to that person. In the case of planning, we are more interested on, well, what was called in the past general problem solving, which is related to path finding, and well, here we have automated planning. So we are concerned on the output will be a set of decisions. That set of decisions will be ordered, so usually we talk about a sequence of decisions. So we are more interested on decisions that relate to a sequence of things to be done in the future. So in that sense, we are kind of tackling the problem of medium long-term reasoning instead of just one step reasoning that we do with other tasks. So a simple very related task is the task of pathfinding, which we all know about from our studies on AI, for those of you who have studied AI in the past, which is the task of Google Maps. For instance, you give an initial point and then an end point, and you want Google Maps to compute the sequence of actions that you have to take in the world in order to go from here to here. And that sequence of actions, as we will detail now, well, are mostly related to like moving from one cross to another cross. That's the case of pathfinding, path planning. In the case of task planning or automated planning, we deal with tasks in which the action is not only does not relate exactly to movements, but also to other type of tasks. So that would be a very coarse separation between pathfinding and task planning or automated planning is that we are interested in combining other tasks apart from just moving in the world. So one example would be generating the plans for the Mars rovers, which is actually done with an automated planner. It's not done on board, so it's not because NASA has some constraints on having full autonomy on the robot, but it is being done on Earth and then just uploaded. The plan is uploaded every day to the robots. So what do they have in common? Well, that goes back to, and I guess that many of you already know about that goes back to Newell and Simon ideas. Well, these two types of tasks, basically, they can be formalized as a problem space. In a problem space, we have a set of states and a set of actions that we can take in those states. Then that's what we call, in automated planning, we call a domain, this definition. Then given a domain, so in the case of Mars rovers, we have a domain. In the case of Google Maps, we have another domain. So for each domain, we can specify many different problems. So we fix the domain, and then we pose different problems. Each problem is specified by initial state, a set of goals that we want to achieve. So it's not exactly a final state, like in most search problems. They fix a given final state. We are interested in achieving a set of goals. So it's a little more general scheme for specifying. So it's a partial state. And then we can also specify metrics. So we could say the planner to minimize the cost or minimize the time or whatever. And then the reasoning, it's similar. Given a problem space, so a domain, and then given also a problem that we want to solve now, we do reasoning by doing search combined with heuristics, because most of these problems are NP-hard or even harder than NP-hard in the case of planning the RPA space. So those are really hard tasks to be solved. Most of them are untractable because we don't have enough computer power to solve them, like chess, for instance. So we have to rely on heuristics in order to solve efficiently these problem spaces. And then the output is a plan, and that's, again, the difference between this type of reasoning and the one-step decision making is that the output is a sequence of actions to be made, to be taken in the real world. So just as a similarity between what Google Maps could, so the type of problems that pathfinding solves and the type of tasks that we solve in automated planning. In pathfinding, they have a map, and we also might have a map or not. So depending on the task that we want to solve. In the case of rovers, they do have a map of waypoints in Mars. In pathfinding, they have the position of the vehicle or the person that you want to move, or the robot. Here we have the position of the robot and many other things, like the position of the satellite or the lander or whatever. And then we can also find other things that you can add into the state, which can help you on making decisions. So like traffic density and meteorology and emissions and things like that. And you can also have things like that related to the rover, whether the robot has taken an image or not, or where the interesting rocks are, and so on and so forth. So this is the state definition with respect to actions. In the case of pathfinding, they usually only have one action, that is going from one node to another node, so one place to another place. In the case of task planning in general, we might have or not movement actions, but we can also have a set of other actions that can do plenty of other things. And then we also have an initial state, which provides the initial description of the problem. And we also have an initial state here in a planning. So you see that there is a similarity between these two tasks. I would say that in general, planning is more general than the type of reasoning that goes on in pathfinding, though the techniques are going to be the same. They are just doing search. I'm not going to go into the details of the formal definition, but there is a famous person in an area that says that you have to add a formula in all the talks, because there is people that love formulas. So it's a small formula here. It's not that much, but it's just to show that you can formalize, and there is a lot of formalization going on these tasks. So you can just have the mathematical properties and things like that. Well, from the point of view of modeling, another, you might consider a main difference between what is being done in automated planning and what is being done in the community of search is that in search they usually code the problem space and all the definition of everything related to the domain definition, they code it in the code. So everything is mixed up. So it's the code of the A-star algorithm together with the functions that generate the successors, which is the domain-dependent information. So everything is being programmed in C++ or in whatever programming language they use, while in automated planning we make an effort to declaratively represent the information about the world. So that has plenty of advantages I'm not going to discuss, but I mean, I'm open to discuss that, but I think that's a much better approach than the other one. The only thing is that once you get a definition like this, then you have to compile it into something more efficient, because obviously reasoning and predicate logic is obviously less efficient than reasoning on propositional logic or even in C++. So you have to deal with this balance between representation power and efficiency. So this is an example of an action representation in PDDL, which is the standard language that we use in planning. I'm not going to go into the details of this action, but this is the navigate action for the robbers domain, where you have some variables, you have conditions, so it's if-then, so you have conditions here that can also relate to numbers, so you can also have numeric preconditions. And then these are the effects, which is the then part of the action that specify what you think it's going to change after applying that action in the real world. So that's the semantics of actions in PDDL. And what you are going to get is a plan, which is something like this. This is the standard representation for the competition, where you have actions that you have to take in order to solve the task that you have given the planner. Okay, so you just you give those actions to the robbers, and the robbers start executing actions. Okay, so some applications before going into tourism, I'm just going to describe very briefly. So one slide per application. I'm very fast. As I said, please stop me if you want to know more about any one of those. About 7 applications that we've done in the past in our group. My group is called PLG, Planning and Learning Group. But before that, let me just introduce some short publicity, because we are quite happy these days because we've been, we have had some success with implementing tools, planners, and other problem solvers. For instance, we were second in the SAT competition, which is one of the main AI competitions there are around. And we were second in the open track, which means any solver that you want to submit. That's the most important one. Then you have more specific tracks, like this one that we were the second also in that track. With respect to planning competition, that it takes place every 2 or 3 years. In the last one, in the non-learning track, there are several tracks. In the general one, we were the winners in the optimal track, which is like the most fancy one. Then we were also the winners of the satisfying track with different planner. And then we had other second positions and things there. And then in the learning track, we were the winner of the learning track also. So these days we are kind of very happy with the tools that we have generated within our group.
Normally here, you have some benchmark to try to test the planners? Or?
Yeah, that's right. So you get, so all of us have at our disposal, anyone can download all the domains and problems of the past competitions. So you create your tool in order to be able to solve most of these domains and problems. Some of them are easy, some of them are quite hard. And then usually you are given new domains and new problems, and you have to show that your planner is able to to compete against the rest.
So this is very objective. It's not
Yeah, it's a quite objective competition. I mean, I could go and provide some details on the competition, but it's
not like Amas. We speak like that.
okay. So there are obviously some aspects that you can discuss whether they are the right way to measure the performance of planners and so on. But I mean that we have some very specific rules, and the winner is very clear. So it was not that clear in the past, in the 98 when it was created, but now it's quite clear. Okay, so let's go to the applications, and the first thing is that I want to highlight the importance of doing domain-independent problem solving. So as I said, the domain definition is given as an input to the planner, and the problem to be solved is also an input to the planner. So the planner doesn't have any knowledge about any domain. So that's one of the rules of the competition, because there were some people in the past that created planners that had some code that said something like, if you are trying to solve the blocks world domain, then do this. If you are going to try to solve the logistics problem, then do that. So that's not allowed in the competition. So the code should be domain independent. Okay, so you are supposed to receive an input that you don't know which input is going to be. So it's going to be specified in that language, in PDDL, but you don't know the input. So your code, your planner has to be domain independent. So that's the most general type of problem solving, because you don't know anything about the type of tasks that you're trying to solve. So in that sense, then you can apply to many different domains, and I'm just going to describe some. I'm just going, as I said, to go very fast on this. So one of the first applications that we did was with together with Ispasat, which is at that time it was the only satellite company, so the company that had some satellites, Spanish satellites. And well, they had to create plans for maintaining the satellites. So every year they have to create a plan, a big plan, on operations that they have to do from time to time with these satellites. And then they have some constraints, because you cannot do some operations while you have the sun there. So you have plenty of restrictions there. So it's not that easy to come up with that plan. In fact, it took them about 1 week to generate the plan for every year. In our case, it was like seconds that we generated the plan. So that was quite interesting. So that was done together with Universidad de Alcalá. I'm going to describe this SAMA project in more detail later. We did also some work with education. So in the case of, it was more oriented towards automatically generating adaptable education plans for students. So if you want to teach AI, and then you get plenty of different students, so imagine a MOOC, or imagine an online course where you don't know the exact, so a priori you don't know the type of knowledge that each student will bring to the course, then you have to generate adaptive courses in the sense that they have to be adapted to the specific student. So we did an architecture that again included a planner. Then we had to deal with all the inputs and outputs related to learning systems, which I guess that some of you might be more knowledgeable than I am. But here we have the planner. That was the one that the core, at least from our point of view, it was the core of the tool that was able to generate plans for each specific student. So you can just then upload it to a specific tool and then run it. Well, what I didn't show the logos, but that was done with UNED, with people in the Universidad de Castilla-La Mancha, with people in the Universidad de Girona, and also Politécnica Valencia and Granada, so several universities. And then it was applied to a company in Granada. In Granada they had a company, and then they had connections with other companies, so they sold the technology. We did some application also for Ericsson research. They had a problem of data mining. So in data mining, you have plenty of different algorithms that you can apply to a given data set. So they really didn't know. So there is no exactly, so given a database, there is no one that can tell you, well, this is the type of task that you have to do to perform in this order. So every time you have a database, then you kind of try out many different algorithms you have. There are some intuitions right now. I mean, there's people that have been working in this area for many years. They start having some heuristics on which is better than which for which type of database. But in general, there is no such algorithm that will tell you exactly which steps will be the best ones for that database and for the task that you want to solve. So what we did is we use planning to automatically generate, given a database and something that the user wants to achieve with that database, then we automatically generated plans so that the user could try out. Well, in fact, the tool automatically tried out those plans with some machine learning techniques, and then they come up and analyze the results and automatically could learn also. So the tool was quite complex. We did some work, some project with Acciona that was in the context of some Zenit project. In this case, it had to do with logistics, so moving goods from one place to another mostly in Spain, but they also have some services also in Europe and in Morocco. Well, the task is quite complex. I'm not going to go into details here. It had to do with planning 300 movements every day. And that's way beyond what most people have had at least published. I guess that from a private point of view, there might be applications that are able to solve these type of tasks. But from the perspective of research or published research, that was much beyond what was published in that time. We've been currently working for many years on this because, well, they had a lot of delays, not because of us, because of ESA. That's a quite complex project that's been done with ESA and with the Spanish connection with GMV. And the idea is to have planned the observation of objects on space using many different satellites, or well, not only satellites, antennas and all kinds of instruments that are able to observe objects in space. So again, it's a planning problem in the sense that we have to plan which satellites to use for which objects and during which time, and so on and so forth.
Okay, the objective for that system is the element in the sky that you want to observe.
Yeah.
And then depending on what they are doing and so on.
Yeah, it
it
depends. So whether planning is needed, that would be a discussion. But you have to consider many different things because so each object is only visible for each satellite only during a time window. It's a repetitive time window because, well, they usually go around the Earth. But you can only use that instrument for observing that object in a given time window. So you have to reason about temporal relationships. And then there are plenty of other satellites that might be looking at the same object, and each instrument has some properties, each object has some properties, so you have to match the properties of each one of them. And then you have some metrics that you have to take into account, whether it's an ESA instrument or it's a private instrument and you have to pay for it. So there are other constraints that you have to take care of it. Whether that's a planning problem, I mean, we are in the verge of between planning and scheduling. So it's not exactly what it's, I didn't discuss the difference between planning and scheduling upfront, but.
It's a long discussion, no?
Well, no, I wouldn't say that that's difficult. So basically planning usually deals with the sequence of actions, no time, and then scheduling deals with the time issue. But you can also do temporal planning. That's what we are doing in this project. So we have planners that are able to reason about time, explicitly about time. So you can come up with a plan that takes into account temporal constraints. So yes, it's difficult because you can mix it. You can do planning and then scheduling, or you can just mix them together. In fact, I will say a little bit about that when I will describe SumUp. So I'll talk about Android later. Now we are trying out some of our techniques with real robots. In fact, we have been in the past weeks in the media because we have some application for therapist robots. So that's for kids, and they have to do rehabilitation for some limbs, like arms. And it seems like, and we have been doing field studies, so we have been taking the robots to the hospitals, and the kids are able to move the arms much better if they are in front of a robot than in front of a human. That's what we are observing. So we are getting a lot of media impact these days with this application. And then we have been doing other things like games, applying it to games and emotions, and generating. Pablo is not here, but oh, you're here. I didn't. You had a bird that's why I didn't recognize you. Yeah. Okay, so I'm not going to talk about that. Sorry, and better because you are an expert on that, and I don't want to say anything inconvenient, especially if I'm being. So okay, let's go with the applications, specific applications for tourism. So we go back to early 2000s, where there was some interest, and I think it's still there, and it's becoming more and more clear during these days, that at some point we will get into the point where we will start generating systems that are able to adapt to the users on a personal basis. So everyone is already talking about it. Well, we were already talking about many other people, but it seems like today we have the tools for having smartphones that are able to adapt to the users and to suggest things to the users. So in that context, you need user models. You need to work on machine learning because you need some adaptation. You need to do problem solving, and that's, I think, we have been stressing that fact, and that might be the main difference between what we claim and what the others claim is that you need problem solving here. You need to think about medium and long-term goals, and then you need human-machine interaction and many other things that you might want to add to that pot of things that you want to use. So at that time and currently there are plenty of domains which would benefit from this type of systems, like traveling, tourism, education, agendas, management. That's what most people would think of. Workflow for when you work for a company and you get the tasks that you have to do each day. Then for some type of companies, and some other applications that I'm not going to discuss. So one of our first attempts to work on tourism and using planning was called MapWeb, which was the PhD thesis of David Camacho, which who suggested to have like three-tiered architecture based on agents. I'm not going to talk much about agents because you're going to catch me here. So, but there was a user interface that was, it was more than a user interface. So he suggested the use of agents at the user level, at the communication with the user. By the way, this is not like very novel. So I mean, most people in the agent world would suggest similar things. Then those agents would communicate with reasoning agents, and those reasoning agents would communicate with web agents. So the application that he was thinking of, he implemented, was suppose that you want to get an integrated travel between using flights and trains. So that's not exactly something that you can do even right now. So it's not easy to do that. There are no automatic tools, at least from what I know. It might be that they have been created already, but not. They're not. At least if there are not many tools right now that are able to combine a flight with a train. There are tools to combine flights, but not with other types of transportation means. And you can also have tools for combining local transportation. That's something that we all know. So at that time there was none. So well, he suggested that you could have different web agents, one for each one type of transportation mean. So he created a grabber for Iberia and for British Airways and so on, and for Renfe and many other companies, which was a nightmare. And in fact, that was the bottleneck of the system at that time, because every time, well, they were changing the HTML pages every day, almost every day. So he had to change the the grabbers all the time. So those, so if I want to go from here, I don't know, to Basel, then I would ask my user agent. That there was a planner here, but the planner didn't know how to combine things. He would generate a very generic plan, like take the flight and take a train or something like that, but it didn't have the details. So it would ask the web agents to provide the details, which are the specific schedules for trains and flights, and then they would go back to the planners would generate the plan, and then it would talk to the user, and then they would do all kinds of things related to user management. So there was an early system that had to do with tourism. Then we got involved in a national project together with all these universities and research centers. UNED provided the user interface, everything related to user interface. The EIA provided the CBR component, so case-based reasoning. And then the rest of groups, we were involved in planning, from very different perspectives. Granada has been working always with HTN, with hierarchical planning. Valencia has been working with temporal planning, and we have been working with classical planning and learning. So that the combination of things we were different, we had different backgrounds. Okay, so what was the context of SumUp? So again, that's something that has been explored already many times. That was not much explored in that time, in 2005, 2006. So the idea was that I want to visit Madrid, and I have 3 days. So please suggest me a plan for visiting Madrid during these 3 days. So we explicitly say plan. So I'm using plan, and most people would say plan. Well, because this has to do with planning, because you have to specify a sequence of actions, or a sequence of visits. You have to take into account, so let me put things. You have to move around some place, so you have to explicitly tackle the problem of route planning, pathfinding. You have several set of places that you might want to visit, but you don't have time enough for visiting all of them, so you have to do something with that's something from the point of view of planning, we call it oversubscription. You have more activities to be put into the plan than the ones that you can actually plan for. So you don't have enough time for all of them. So you have then to reason about utilities, and you have to reason about times, and you have to reason about other things. You can also add things like where I want to eat and where I want to stay in the hotel. As I said, you explicitly have to reason about time, because visiting a museum doesn't take the same time as visiting just looking at the house. There are plenty of very different people that travel, so you have to take into account user preferences. Even if I travel, if I am the one traveling, I might travel with my family, or I might travel for just photographing, or I might travel alone for just business. So the type of travel that I might do might also vary, so it's not always the same. At that time, and it's more clear now, we access that has to do with human-machine interaction, and we didn't deal with that. That was UNED that dealt with it. So you have to combine all those things in order to generate a plan for a visit, okay? And that we all do that. So that's something that we do. So the architecture of SumUp was something like that, where we have the user here, we have everything related to user modeling and user preferences and user interface here. That was done by UNED. Then we have an ontology that is behind everything, and that took us most of the time of the project. So in fact, we didn't generate more because we spent a huge amount of time doing the ontology. There were no not many or no ontology at that time that was able to represent the type of things that we wanted to represent at such detail. So we wanted to have a very detailed representation of that task. And then we have planning here, that is the one that generates plans. Well, in fact, we generated a set of plans instead of only just one, because the user might want to just choose between different plans. And then in the middle, we use the case-based reasoning because, well, what the user provides as a user preference on, well, I might say if I want to visit Paris, then I might say, okay, I want to visit the Tour Eiffel. But I might not be sure about what are the places to visit. So I might only say I might want to visit one museum and something like that. So you need something that matches user preferences with the knowledge of the world, of the places that are actually there. So what it's called points of interest or POIs. So that case-based reasoning was provided that enriched model of the world to the planning component. So the planning component must know which activities have which utility, which preferences, which time, and so on. And we didn't have all this information in the ontology, and we didn't know also the user model. So we needed something in the middle that would say, okay, that user is has this specific model, and then what they did is they obtained similar users. And then from those users, they generated the preferences. So they automatically incorporated the preferences of those users to the places that were in that place. So that's something that, again, that it's being done now regularly. There was not much at that time. So
where is the control in this architecture?
So I'm not sure about what you refer to as control, but well, the user specified something to the user interface, and then the user interface would pass the information to the case-based reasoning, which would pass the information to the planner. The planner would generate the plans, and then would come back to the user. What are you expecting? So
I think that
to have a module that call the planning or verify if the plans are okay, and then call to the case-based reasoning or select the user model. I don't know.
Well, we had a small control program, but it was very simple, which was called the user model. Once the user has specified the inputs, it was just an interface, a simple interface. Then it incorporated that information to the case-based reasoning. So you call the case-based reasoning module. That generates the output that we required for planning, and then we call the planner. So in our case, it was not that difficult because, I mean, it was not a tool that we were going to sell anyone. So it was just more. So in fact, I mean, what ends up happening in most projects of this type is that while they worked kind of separately from us, apart from coming up with a common ontology, they worked quite also isolated from us, but we were expecting a given input here, and we were also working in a separate way from the rest. So we met a lot basically to come up with the API as well, so the ontology and the connection between the modules.
The ontology is a real ontology, or is it an information model?
I'm not an expert on that. So from a technical point of view, implementation point of view, it was well created with Protege and then translated into Eclipse. So we had everything, all the objects there, and so I'm not sure whether you would call it a knowledge model or a knowledge base or ontology, or so ontology in the sense that we all share that model. That obviously it's not a shared model with the rest of the world, so it's not exactly a real world ontology. I'm not sure how many ontologies are there, even currently. So, but there were none at that time, so we had to generate it by ourselves. So whether you call it ontology or you call it knowledge base, that, I mean, I think that there has been a lot of playing with words in AI, and I'm not going to go into the detail because I'm not an expert on that topic. So I don't want to say things like I would want to retract in the future. But I think, I mean, for me, ontology is the same as a knowledge base and the same as a set of objects with some properties and the same as many other things. But As I said, I'm not an expert. I don't want to get into trouble here. So, okay, you call it knowledge base, and then we are happy. Okay?
Going to the issue of the control. For example, you make a plan. When I am, for instance, a tourist, I am always changing my plans because sometimes you say, okay, well, this place is wonderful. Let's stay in this terrace now for some time, even if the planner is saying something, no? So you have to replan a lot, no? So how are you considering this here?
Yeah, I didn't talk about that on purpose because we didn't have time during the project to do that. So we, as I said, we spent a lot of time generating this ontology. At the end, we didn't have much time. It was in the project, so we had some tasks related to replanning. Yeah, in fact, we had the next project. Well, it was not exactly the next project. The 2 projects later, we came back to the execution thing because that's a key issue in planning. So if you would talk with most people attending the planning conference, well, now it's half and half. But it used to be like most people would only care about planning. So they wouldn't care whether the plan is going to be executable in the world.
Yeah, this is completely unrealistic.
It's unrealistic, but that's...
Then this is an academic issue. That, I mean,
well, we all live in the academic world, so...
this is not, I mean, science needs verification. I mean, you can. This is like all the formalization using logics. Okay, the logician can enjoy with that, with this, and also for engineers or for real practice. This is I mean this is.
Well, but you have to. No, I don't think it's catastrophic. But you need to combine the 2 of them. So you have to combine the formal is a formal issue because you have to solve tasks efficiently.
From an engineering issue, the question is this formalization useful for solving real problems? For example, question is, do TomTom use formal logic for implementing TomTom, which is a real application?
No, obviously not, because but the rovers are being programmed using logic. Most rovers are being controlled right now by using logic.
You say this,
That's a fact. I mean, I'm not going to say that logic is the savior of the world. It's my hammer. You might have another hammer. That's fine with me. So if you work in neural nets, I'm sure that you will say, okay, neural nets are able to solve all these problems. In fact, I'm also able to do planning with neural nets. Okay, so it's fine with me. I mean, I'm not going to complain. And I'm not also going to complain that there is part of the academic world that decides to work on formal issues. I think it's needed. And there is also another part of the world. You are not talking to a very formal person. So I've been involved in projects. If the biggest guys in planning would come here, they wouldn't talk at all about projects. They would be talking about heuristics and abstract spaces and many other things that are quite interesting and quite useful.
No, the question is about this.
No, but as you say,
the neural networks is a good example because people working on neural networks say, no, give me a problem and maybe I'm going to solve with neural networks. Planning people say the same, all the formal people say the same, but for an engineer we need criteria to say, well, for this problem we can use this, or maybe to solve a real problem I need a little bit of this, a little bit of this, a little bit of this and this, but you should recognize that your stuff is not a universal.
No, I'm not saying, I will never say that, I mean, I'm not saying that planning is able to solve all the problems of the humanity. Well, I mean, I don't know. Well, I mean, I think it's not that bad to do some planning from time to time, but the real world. No, but what I'd say is, well, I mean, it's obvious that you need to combine planning with execution. And so that's why we came back to that, and then most people are starting to be more interested on execution and replanning and monitoring. So that's something that is being done right now. So it's not that we live out of the world and we think that all the plans will work forever. It's a part of the community is only interested on the planning by itself. But it doesn't mean that all the community is only worried about planning by itself. Its connection with the, in fact, we have a track, a specific track in the planning conference that it's only devoted to applications. So it's very, and you have plenty of them. So you can just have a look at the last proceedings, and they've been used in many different applications all over all kinds of things. So it's not, the planning technology is, the planner is just a piece of a code that has to solve a bigger problem. And the bigger problem means you have to deal with states and goals, where those come from, where do actions come from, how do actions are executed in the real world, how do you monitor whether the execution is the right one or not, and so on and so forth. So you have to deal with all these tasks.
No, I agree that this is, in problem solving on AI, the problem is this: you have a problem to solve, and you need to formalize, and then you need to assess if the problem has been solved or not. But for example, in your application there, you call planning, is this component, but for example, I see in tourism, as you say, this, the initial plan in tourism is a collection of goals, a sequential collection of goals with constraints, generic constraints, and a specific constraint associated to your goals.
Mm-hmm.
Well, you can try to solve this with planning techniques or with others,
Well, I mean, I'm just presenting what we did.
No, okay.
So I'm sure that you are very intelligent people with other tools, and I'm sure that you will be able to generate the same application with other tools. And it might be that this application is better than ours. I'm happy with that. So I'm not saying how anyone should perform research. So I'm just happy to hear about what anyone is doing.
Which are the specific advantages of planning?
We have to continue. Yeah, we have to moderate you. You are the moderator.
Okay.
So we can talk that about on that.
With wine.
With wine. Okay, so let me be a little bit more specific. You might already guess what the inputs and outputs are. You get the place where you want to visit and the number of days of the visit. You get the activities that the user might want to visit, or you might infer those activities with the utility of each activity from the similar users. So you have to deal with POIs, you have to deal with transport, with eating, and also with some other places. And then you have to combine also with user preferences, like when that person wants to eat, or when he or she does eat every day. What is the estimated time that this person spends on museums, and so on and so forth. And then the output is a set of plans with good utility. I'm not going to talk about optimal utility, I'm just going to say good utility. So you have to deal with time. So you have to, in our case, we deal with a simple model of time, a linear model of time. That means that we don't have parallel actions, concurrent actions, because we only consider a visit of one person. So even if there were a group of persons, that would be considered as one entity. So then you could have richer models where you have more persons that could split at some point and then join back or whatever, and then we would have to have a more complex model of time. But you have to take care of temporal restrictions, constraints in the actions. We also had to deal with costs and time. So we used a planner that we developed that was able to do that. You had to also to do route planning. In fact, we did it by ourselves instead of asking Google Maps to give us the best route from one place to another. Then we also had to deal with having more activities than the ones that we could actually plan for a given day because of time. You don't have enough time to do all of them. And we used something that is clustering that I'll talk a little bit later if I have time. And then we also wanted to, and we specified how to do planning and execution. which has to do with the uncertainty of the world, which has to do with changing plans and things that happen. The museum is closed. I mean, the bus stopped and things like that. Well, the simplest answer to that question, and what most people in planning would tell you, is you execute actions, you monitor the user, in this case, executing actions, and then if something is wrong, so you cannot, for instance, execute the next action, then what you do is replan. So you get the current state, the past goals, and then you replan again. So that's the standard way of dealing with execution failures. And that's not difficult to program, so it's a simple thing. So one interesting thing that we did is that we were using a backward chaining planner. Well, currently it's like all times. But the interesting part of that planner was that it allowed us to, when we consider using the move action, to call an external route planning algorithm. And then that route planning algorithm would compute the A star or whatever, and then come back with the cost of that action. So we could, from the planner itself, we could call another planner or another problem solver, and then come back with the solution of that planner to do something. And that's something that is not easy to do with the current tools. There are no tools that are currently able to do that, very few. So that's something that was interesting that we did at that time. So this is the type of, well, obviously this doesn't go directly to the user, but it's the type of plans that were generated with temporal and cost information here that you could use.
One question. So it takes into account that, for example, if I'm visiting Reina Sofia Museum, and then I want to visit also Thyssen and Prado, and I have plenty of time this day, so it probably says go first Reina Sofia and then Thyssen and then Prado, because they are the cost moving from because I'm basically Thyssen is in between Prado and Reina Sofia.
Mm-hmm.
So you can start in Prado or in Reina Sofia and then go in between to this. It will take into account this, the time that from going to one point to the other, you can visit some interesting places in between.
Well, in the case of sum up, so that depends on the goals that you pose to the planning problem, because you have, as I said, a list of activities that you are not able to visit all of them, to do all of them. So you have to select a subset of them. If the ones that you have selected, that the CBR system selected for planning, I mean, there is a better plan in terms of cost or time than the other one, and the user has specified that he or she wants to minimize cost or time, then the planner would generate the plan according to that.
It would be indirect. I mean, it would say, if you want to maximize doing these activities, then probably you should do, the order should be this, because in this time in this way you save time.
Yeah, especially, I mean, suppose that you have three goals, that one of them is here, the other one is here, and the other one is here. So depending on the schedules, you might not have time to go from here to here and then come back here. And the planner would, by doing simple temporal constraints, they would notice that it would have to go from here to here and then here. So it would be indirect, the way in which, yeah, it would generate the plan. And again, as I said, it's not optimal planning for optimal planning. So optimal planning is a very complex task. So from a theoretical point of view, it's PS space, which is really bad. So we don't aim to optimal planning. So there is people in the community that only work on optimal planning. As I said, I mean, that's a choice. In fact, I had one student that only wanted to work on optimal planning, and he got the winner, so it was a good job, would work. But I'm not particularly interested in optimal planning. I don't think people do use optimal solutions. Even if you talk to companies and they say, well, we want to find the optimal solution, they don't really care about the optimal solution. They just care about a good solution. So they just care about you taking into account within the planner that a given metric. That's the key issue. So if you are able to reason about a cost or time within the planner, then that's fine. That's fine for most applications. Okay, so now we go later on time. That was done like 3 years ago. with together with ALSA and Minube and some other companies in the context of an Avanza project. And in this case, well, the context is this ALSA, you know that they have buses and they take people from one place to another, and they wanted to have some onboard entertainment, like in the airplanes. So what basically happened is that they were looking for a university because the constraints of this type of project is that they needed a university. And they say, okay, what can you do? I mean, I do planning. Okay, pues just try to do some planning. Okay. So they didn't really care much about what we did. But in the project was Minube, which is, you might already know because they have been quite active since then, having some spots in the TV even. They are kind of a TripAdvisor, but from a Spanish company, very small company. But they have a database of POIs together with utilities, with numbers. They have all kinds of scores, but we use one of them. So we say, okay, so if someone is traveling from here to Oviedo, that was one of the routes, and you might want to suggest routes for that person. So the person might be there and say, okay, suggest me what to do in Oviedo. So I have 3 days in Oviedo, just tell me what you suggest. So that was the idea. But in this case, with respect to the previous project, and I'm going to say a little bit more about that, we had some knowledge on utilities, which we didn't in the past, because we had to manually enter all the preferences and all utilities in some app. But now we have tools and social networks that allow us to solve that task. So what were some of the bottlenecks in some app? Well, the origin, where do preferences come from? That's a hard task, because you have to tell the system enter manually all these numbers. But in this case, we had Minube, so we had access to the database of Minube, direct access. We could retrieve all those numbers, and so we had, for each place, we had a list of POIs, and with each POI we had a number. So that's pretty nice from the point of view of problem specification, because we already had some knowledge. The second thing had to do with maps and route mapping and so on. So what we did is the simplest thing, is that just consult Google Maps. We are now doing the same thing with OpenStreetMap, but we are not yet there. But so we just, whenever we want to know the cost of going from one place to another, we just call Google Maps. And well, we have these constraints, that number of accesses per day, but we never reached that yet. The third issue is the issue of our subscription, which again is one of the hardest points in planning for tourism and other applications like rovers. They also have the same problem. So what we did is clustering of goals clustering. So what the idea is if we have 3 days, to generate 3 clusters, each cluster with a similar amount of total preference of utility. So that's the problem that we had to solve. The next issue is that in some app we had coded for each user, then each user would have to provide manually that information. I usually eat from 1 to 2. I usually prefer to eat from 2 to 3. So instead of that, we used drivers, which are used in other applications related to virtual characters. So we introduced hunger as a variable that increases over time, and we just set up a threshold. So whenever you go over that threshold, then the planner automatically generates an eating action. Okay, so that's we think that it's a more elegant academic solution to just coding for each user when I prefer to eat. Just do it with this driver. And in fact, we are considering using other drivers, but we finished the project, so we didn't do it. But being tired, so that's the usual one in tourism, because people get different tired.
The same idea like in Sims. You were cheating people like Sims.
We were what? Cheating?
Treating people
like
the Sims, the game.
Yeah, well, I mean, the Sims are treating is like a virtual character of people. So they were inspired by how people deal with the world. So it's the same thing. So yes, that's the, and in fact that thing of drivers. So we have now, we are in the process of being accepted a project in the national on goal management, because we think that's the next thing that should be worked at in planning is where do goals come from, and that's a key issue. And one of the things that we'll surely come up with, we will work on is this idea of drivers. So what are our drivers, and each one of applications drivers. And then we had the problem of combining planning and task planning, and well, we dealt with it. Well, first doing calls to Google Maps, and then doing two calls to the planner. One for coming up with a good plan related to utilities, and the other one coming up with a plan. Once we had a plan for utilities, then improve that plan with time, so that we had more free time for the visits. So this is the architecture. Again, that's not something, I don't know whether that you would call that a control architecture or not, but we have, again, something very simple. We don't work in human-machine interaction, so it's something very simple to get the input and the output with the user. We have the tourist plan manager, which is like this control module that calls the planner, accesses the database of Minube, and accesses Google Maps for the distances. With respect to clustering, I'm not sure, I guess I'm over time, so...
No, you can go ahead, because
I'm just finishing, I think.
an interruption. So.
Okay, no, but I'm happy with the interaction, so
No.
I'm happy to discuss
But
things.
your
So,
schedule is completely
okay, my plan.
completely broken.
No. I mean, in fact, I prefer plans like this.
No, okay, but there are interruptions.
No, then you have to replan. That's good. Okay, so the standard solution for goals. Well, there are other solutions. I'm not going to discuss them. So one of them is using clustering, k-means clustering. But if you use, for instance, coordinates for each POI, then what happens is that it will, from a point of view of utility, it might be that, well, so it will cluster places that are close together from a geographic point of view, but not from a utility point of view. So you might end up with a day where you have to see all the important things, and then the next thing you just see like random things, which we thought it was not a very good solution for this problem. The second solution is the one that we used in SumUp, which was having like a function like this to measure the similarity between for using for clustering. But again, it was like a very complex formula, and it had all these parameters here that we didn't really know how to deal with. I mean, you can always ask the user, but it was kind of a difficult function. The solution, the simple solution that we came up with in this project was using balanced k-means, which is taking into account utilities instead of distances. So we set up a limit on the number of POIs to be visited every day, and then we just assign first the POIs with best utility. So that's the main idea. So I'm not going to go into details, but this is the main idea. So, for instance, in the case of London, in 3 days, that will be the output of the clustering. In fact, this is the output, one of the outputs of the system, graphical outputs of the system. So you see that it clusters together the green ones, including this one, which is far away from the other ones. In fact, it's closer. This is closer to this one, but it prefers to like cluster in this way. Okay, so related to utilities. So you would have an average of utility for each day, better average. So you would have a mixture between interesting and not so places. And in this case, I'm not.
Sorry, but they are far, but probably you can get from one point to the other easily, right? I mean,
yeah. I mean, it accounts for distances and time.
Distance is time.
Time.
Getting there.
Time. Yeah. It accounts for time. So all these plans are feasible plans.
Okay.
From the point of view of physically doing the plan,
I mean,
executing the plan.
Distance between points is the time that you take to go from one to the other, not the distance.
Yeah. In fact, we used Google Maps in two modes. One of them was walking and the other one was driving, and then depending on the distance, then we used one or the other. So it's not very sophisticated, but it accounts for time somehow. So okay, so I think I covered that. We used another planner. It's not a state-of-the-art planner, so we are using CDP, which is not a state-of-the-art planner, because the state-of-the-art planners are not able to deal with this type of constraints. Those are called numerical preconditions, and the competition doesn't deal with that. So the competition that only deals with a very restricted PDDL, so it's not the full language, but the full language is quite flexible and quite powerful. So it allows you to do things like that, but you are not able to use like a state-of-the-art planners to do that. So you have to deal with planners that are richer, that can deal with richer models. So in this case, you have, for instance, visiting a place, the user is at some place. This is the driver, the hunger driver. So for visiting, you are required to be under the threshold of hunger. Otherwise, it would select the action to eat. And then, it has some temporal constraints here, and then some other things, bookkeeping here. And the effects, it has visited the place, and also it updates the functions that deal with time and hunger and things like that. So it's basically what the model of, in this case, of the action that visits one place. This type of output that the system will generate or generates. So you have the time for each thing where everything starts, the suggested time to spend on that place. Again, it depends on people, and they might vary it, and then you would have monitoring and execution and replanning. And then it also considers walking actions here and eating actions here. So, and also there is this issue of free time because, I mean, if you generate a plan that doesn't have any free time in the middle, then nobody will be able to do it. I mean, you end up, I've done it in the past, but you are like exhausted at the end of the day. So
how do you produce this free time?
So it's basically variable. It's like in LaTeX using H field. So you just fill out. So probably there is some temporal constraints here for visiting the James Park. So and eating. So between visiting the park and eating.
So you say, okay.
Yes, because probably it's not, the hunger is not about the threshold. So you just go let the person just go around a little bit and shopping and things like that. So this is the type of output. I mean, we are not people working in human interfaces, but well, you have the whole plan here. It's a very, very high level view of the plan. Then you can click on each day, and it will show you the. I don't have the biggest one, bigger one, but I can show you. So it incorporates the routes here for each day. So it puts all the points and then the connections among those points. And then you can also click on each one of the POI and the visit, and then it will tell you where it is and so on. So it will connect it to Google Maps or whatever other tool. I'm not going to go into the details here, but we have some numbers there because obviously you have to publish, so you have numbers here. There are other people that have been doing that. Up to the point where we started the project, and obviously in the case of SumUp, there was known, as far as I know, a commercial tool or commercial web page that allows you to do that. Okay, so most of the web pages would allow you to select points from a list, like clicking, and then put in like the routes, and those points are going to be on these days, and these points are going to be on those days. Since then, the one that we know, I think it is this one, City Trip Planner. They do have now an application that does something very similar to what we did. Okay, so now it's becoming the point in which we are going to see this type of tools more often. In fact, we could have been the first ones, but Minube didn't just go push further, and then I think it was a pity, but they preferred to do their business. So just to sum up, we do believe that planning can be used for many tasks, for solving actual tasks from an engineering point of view also. It allows, it has some rich language to represent knowledge, so you can use, it's a knowledge-intensive task. And it also combines it, I didn't talk anything about the inners of the planner. That's something completely different, but then you have to deal with heuristic search and then very sophisticated heuristic search. So there's plenty of work now being done on that, and we have had very smart students working on that also, and that's why we won the competitions. And then with respect to these two applications, well, they generate personalized plans. It's an integration of, well, you need in all the problem-solving tasks, you need to integrate many different things. It's not only planning. I'm not claiming that these two are like commercial applications. I'm just claiming that they are the core, they can be the core of a real application. It's just, I don't have enough time in my life to do commercial activities apart from my academic activities. But in case anyone wants to like create a company that sells this type of technology, I think there is a pretty good niche for this type of technology. Okay, so I'll stop here. Okay, thank you.
Regarding this last point, what are the model of your software? Is open to use, open software? Can you use it for commercial purposes?
That's a good question. And I don't know the answer because I'm really bad at, I tend not to do the paperwork before the project, so I just tend to rely on the people in my administration and Otri to do all the paperwork. And sometimes when I read what I signed, it's scary. So I'm not sure about this because they are not using it. So I mean, I don't know any reason why I couldn't use this to create a company. But I would have to go into the details of what I signed at some point. I mean, you can always change something from what you did, and then.
So is the planner you're working on now, it's downloadable, at least for research?
Well, all the planning technology is open source. All. So if you want to use a planner right now, you just go to IPC, which is the planning competition, and you are supposed to provide the open source. If you compete in the competition, you are supposed to provide open source. So you have temporal planners, you have optimal planners, you have satisficing planners.
What's the name of those planners?
Well, we have several. So we have, yeah, that accounts only for the ones that won the competition, but we also have others.
But those are the competitions.
Yeah, well, they are the best. Yeah. So for optimal, I would say the Simba. In fact. Well, yeah, he will have it open at some point because this guy is already working in Germany and he's finishing his PhD right now. He's like, if you want to hear about optimal planning, he's defending his PhD on June, on June 2nd, I think. EVACOP is a portfolio. That's pretty much the state of the art is on portfolios. So if you want to win, you have to combine several planners. That's what we did with EVACOP. RPT is a stochastic planner. Again, everything is open source. So in any case, if you want to have the code of any one of those, just let me know. But they should be at some point in the IPC. It takes some time for the people to clean the code and things like that. But because right before the IPC, you are in a very stressful mode. So you just program as mad and then just hope that the code will work. MiPlan is also a portfolio, and eRoller, well, those are learning systems. So this JAMA just learns how to combine heuristics, and eRoller learns control knowledge, very old type of control rules.
You've also been doing some case-based planning? Do you have any case-based planner?
No. Case-based planners currently, I wouldn't say they are not able to compete, I would say. It's very hard because for case-based planning you would have to compete in the learning track. And there was no case-based reasoning planner as far as I remember in the last competition. So that would be the place where I would place a case-based planner. But our case-based planner is already old, so it's based on a previous planner, which is not the state of the art. So we would have to recode the whole thing. So, but there is people like Ivan Serina, you might know that he's having a good planner right now, so a case-based planner, and it might be that he will compete at some point.
Would you say that, because planning goes back, you mentioned Alan and Simon, a lot of time in AI, and you have competitions every year, so every year you have the best. And I wonder if there is some stability in the research in planning. I mean, will it be a regular component of our system, this planning component, using standard technologies and so on, instead of being a matter of pure research?
I'm not sure what you wanted to know, but so at some point there was so you know all these competitions like focus on specific aspects of the competition, and some points in time there have been like the winners for several years. So at some point there was.
Different from year to year?
Yeah. So at some point it was metric FF, and we have done some code on top of metric FF. But in the 2006 to 2008, there was this guy called Malte Helmer, which changed the whole thing because he created this. It's not a planner; it's a framework for generating planners. That is called fast downward. So you get fast downward code. What you get is a set of planners because you can configure it in many different ways. And that's what most people use right now. So you just download fast downward code, and then you just configure it as you like. And you can do A star, or you can do weighted A star, you can use FF heuristic, you can use landmarks, you can use Merson streak, you can use plenty of different heuristics, plenty of different search methods, and then you can just combine them as you like. So most people currently are using that. I don't know whether that answers your question, but there is some stability from.
Yes, but you're telling me there are things around about planning. My question is more, is there some standardized method of combining this in order to provide a solution, or this just here's the puzzle, go take the pieces and look for ways into combining them in order to have your solution?
Well, so what we have, I think the main thing that we haven't standardized is the language. Even if not everyone works with the same level of the language, but because as I said, it's really powerful. Most of the people work with a subset of that language, but even with that, you have a common language. So if you want to do something with planning, I would say, first of all, understand how PDDL works, because then if you are able to model your problem in PDDL, you can just download any planner to solve it. And then that depends on the type of task that you want to solve. So if you have a temporal task, then fast downward would not be the one. Then you would have to use a different algorithm, like optic, or well, there are others that are able to solve temporal planning tasks. If you have some uncertainty there, and you want to explicitly reason about the uncertainty, then there are planners that are based on MDPs, they're the ones to use, which is a different type of technology. And they don't usually use PDDL. They use a different programming language, RDDL. So depending on the task that you want to solve, you might want to use one or the other. So there is no methodology in the sense that there is no standard methodology in the sense that you should use this one and then this other one. You just have tools that you can combine as you like.
Regarding the goals, you say that in some app you have to manually type in the ontology all the goals, and that later on this was solved with Minube that identified the goals in each city?
Yeah, so in some app, so at that time there were very few, if none, social networks where people would enter their preferences on specific poise. So then, in order to test our system, what we did is we took Valencia, and then for Valencia we manually generated all the poise of Valencia, and then we gave all these numbers, and then in order to test the system, because there was no other way that we thought of testing the system, apart from giving it like giving it as a present for many people and then letting the people like vote for the places. That would be another alternative, but we don't work on that area. So
with Minube, like you are able to automatically extract, like if you are recommending London, then you say, okay, this is Saturday, and on Saturdays Portobello is the best day. So is that retrieved from the net, like automatically, or if you have a budget, then you can say, my budget is this, and I'm recommending Madrid, so Prado is free on Tuesdays. Is that type of information in the net retrieved in your system?
no, so the information that we retrieved, we could have also retrieved that information if it's in Minube. I'm not sure if the cost, even the time is not in Minube, so the opening times are not exactly in. They were working on it. I'm not sure whether they already have that. But, so we only retrieve right now is the score. We can reason. So if you give me the cost and you give me the times, we can reason about anything. But the issue is that getting that information is one of the hardest parts.
Yes.
So that we.
Like using a web crawler, you could like.
Yes. You could always generate a crawler. Yes. But I mean then we would have to work on things that we don't usually work, like. We would have to generate the crawlers and the wrappers and so on. And as I said, that's a kind of a nightmare, at least from our experience, because people tend to change the structure of the web pages.
And
so
regarding user modeling, like if you are making a planning to a family, and you say, yes, you are recommending a museum, but how do you ask preferences? Like maybe if you are recommending London, maybe a kid would prefer to go to the Natural History Museum, or because you have only one day to recommend museums, how you select which museum over all the ones in the city that you include in your planning?
So right now we are not covering sophisticated things. Okay, so we stopped the project and then we are deciding now what to do with it. So for our commercial applications, then that would be the type of things that we would have to consider. And then I would tell you how would I do it, but this is not how we already solved it, because we didn't. Okay, so
when the user uses the application, it doesn't receive initially a list of, I like Italian restaurants, these type of museums, they don't indicate their preferences before organizing the plan?
So in the case of SumUp, we did that. In the case of On-Road, we didn't. But again, because we didn't want to deal with the task of human-machine interaction. I mean, it could have been easy to supply a small interface, and then the user would select which type of places he or she prefers, and with which number and so on. But we didn't. So, and then in case we would have done it, then we would have to combine that score with the score of the people in the social network. And then we have a different task, which is how to combine scores, recommendations from different sources of information. And then probably you have to have some weighted thing or something that we didn't work on.
Okay, so we are going to close. Thank you very much. Thank you, Daniel.
Thank you for
all the
letting me talk about this.